Finishing up in section 10.2 here with our last example. Here again we're trying to rationalize our denominator. And I know that our denominator isn't a square root, guys, but we have a fraction inside of our square root. So another way of writing this is the square root of 7s divided by the square root of 3. So rather than having a fraction inside our square root, we can make a fraction from square roots. So here, in my numerator, I can't simplify that anymore. But in my denominator, with that square root, we're going to try and get rid of that. And the only way to get rid of a square root in our denominator is to multiply by something that's going to help give us that perfect square or that pair we're looking for. So since I have a 3 here, I need to multiply by a second 3 because that's what's going to give me my pair of 3's in my denominator. Keep in mind, though, that whatever we do to the denominator, we also have to do to the numerator. So since I multiplied the denominator by the square root of 3, I have to multiply my numerator by the square root of 3. And because we're multiplying with square roots, we can take whatever's inside any of our parentheses and multiply it together. So here, in the numerator, I get the square root of 21 times s. In my denominator, I have a pair of 3's. Those come out as a 3. So I no longer have a square root anymore in my denominator. So I have 21s inside my square root over 3. Quick recap here. Radical expressions can be simplified using the multiplication and division properties of square roots, and rationalizing the denominator of a radical expression removes the radical from the denominator of the expression. And that's all I have for section 10.2.